All right, everyone. Going to walk through here in this set of videos. Going to walk through screening for independent sample t-tests in Stata. This is just the same data that we went through in class with SPSS, but want to go walk through of screening procedures in Stata, and then also in the follow-up video we'll go through and actually run the independent sample t-test analysis and then calculate some effect sizes from there. But for this example here, we've got our MVA t-tests that we went through in class. The handout that we'll be working with for Stata is the independent sample t-test screening with the MVA t-test set. So this is what we'll use to follow along here. And for the setup for this project. So again, as we walk through in class, what we're looking at in this hypothetical example is gender differences in marital satisfaction in motor vehicle accident survivors. We have 22 women, 5 men that do meet diagnostic criteria for PTSD subsequent to a traffic accident, and we have these individuals completing the Locke-Wallace marital adjustment test. Scores here range from 2 to 158 with higher values indicating relationship satisfaction. We also had people complete the Marlowe-Crown social desirability scale. What we're looking at here is tendency towards social desirability, socially desirable responding in men and women in the sample. So if we do see differences in satisfaction, we'll say that this is a check to maybe see whether or not people just men and women tend to respond to things in more socially desirable ways. So based on previous research, we're hypothesizing that women will report greater levels of marital satisfaction than men, but we're not expecting too many differences in terms of socially desirable responding. So that's the setup for the problem. Again, I've opened up the data set here in Stata. Remember, if I go up and click this icon here, this will bring up my spreadsheet with the data. Here we're working with a smaller set, just a handful of cases here, so this will be easy to kind of walk through and see, but we've got that. And then what we can do, remember, if we click this will open up our do file editor, and we can go through and type in our stuff here. Don't need to do that for this one. I've already got a syntax set up, and we'll work through this in the example. So first thing we want to do with these data is go through, see what we have in terms of missing data, and make sure all of our data are within bounds. So what I'm going to do, and here we've just got a small set. We were only working with, looks like 27 cases, but we've got a couple of different variables that we're wanting to look at, the Locke-Wallace and the Marlowe-Crown. And one thing, particularly with larger sets, that can be tricky is figuring out what proportion of, or what identifying cases that have complete data for your analyses. And one way we can do this in Stata, it's pretty easy. If we create a new variable called check, okay, what this command is doing, it's saying egen, so this is generating a new variable called check, but the egen command allows us to enter specific functions like means and totals and things like that. Here we're going to request Stata identify for us how many of the in the Locke-Wallace and Marlowe-Crown scores, how many of those variables are present. So we're looking for non-missing variables for Locke-Wallace and Marlowe-Crown. So egen check equals row non-miss Locke-Wallace Marlowe-Crown. If I run this and then take a look at my data, it says it looks like I've created a new variable called check, and for case 15 here, subject 15, I've got 1, 2 values here, so we've got 2, 1, 2 values here, 2. And if I go through and I sort by my new variable check, what this is going to do is it very quickly brings up my one case that has missing values here, and then if I scroll down, I see that all my other cases have full data. So I've got one case with missing values. It looks like participant number 132 is a female participant. Looks like they're missing Locke Wallace and Marlowe Crown scores. So what I would do is I would want to go through and write that down somewhere and make note of it, because I'm going to have to summarize the screening information later. So this person is missing scores for both outcomes. So we're just going to go through and delete that case there. Yep, say we're going to drop that, and then what I want to do is go to File, Save As, could just call this scrap or something like that. That's just going to be a working set. This way I'm not fooling around with my original set of data. That way if I make a mistake or make changes to it or things along those lines, I can always go back to my original. Okay, so we've got one case that we noted missing values for Locke Wallace and Marlowe Crown. So we've noted that. And so what we can do now is just go through and get some summary statistics for these variables. Now, remember, I'm running an independent sample t-test. So I'm going to compare Locke Wallace and Marlowe Crown scores across men and women in the sample. And so remember that when we're screening for independent sample t-tests, we need to look at distributions separately across my individual groups. Okay, so what I need to do is tell Stata to look at the distribution of scores for the Locke Wallace and the Marlowe Crown in men and in women separately. Okay, and to do that, we're going to use this by sort command. For many commands in Stata, we can hit by sort and then indicate what variable, grouping variable, we want to split that apart with, and then we can go through and run our summary command. So here we're saying by sort gender, so split it by gender, and then look at summarize Locke Wallace, Marlowe Crown, and then this detail command. So we hit comma detail. This will give us skew, kurtosis, a bunch of other types of statistics that could be helpful in certain situations here. Okay, so what I'm going to do is I'm going to run this and then take a look at my output here, and we'll see that Stata has successfully split up information for the Locke Wallace and the Marlowe Crown for men and then for women. Okay, so we can go through and take a look here. One of the things I'm noticing, first thing I'm noticing for my male sample, I've only got 5 men in this sample relative to 21 women. So we've got a huge imbalance here, and that's problematic. My sample for my men is very, very small. This is just a big problem in terms of thinking about stability of our estimates, things along those lines. But it's the data that we have, but certainly something I would want to mark down in my screening summary. If I go through, first thing I want to do is make sure and take a look at the range and see if the range for both of these groups are within expected values for the Locke Wallace and the Marlowe Crown. So if I look at the Locke Wallace, my smallest score is 45, my largest score is 114.65, and if I pull up my values, Locke Wallace ranges from 2 to 158, so 45 to 114, that all falls in well. So all my values are reasonable. Same thing for the Marlowe Crown, minimum of 10, max of 26. Marlowe Crown runs from 0 to 33, so we're good there. Okay. Let's go down and take a look at my women just to see plausibility of scores. 64 to 140. Again, that's falling within reasonable range for the Locke Wallace. 11 to 24. That's reasonable for my Marlowe Crown. So in terms of accuracy and plausibility of my data, I had one case, a woman with missing values. We got rid of her, but everything else looks to be within range. Okay. So next thing I want to do here is go through and take a look at my skew and kurtosis values. Again, I'm looking at sort of rough guidelines, skew or kurtosis values greater than 2 start to look maybe kind of problematic, or things I might look into a little bit more. For my men, for my Locke Wallace, have a skew of close to 0, negative 0.04. My kurtosis value 1.37, but remember that in Stata, 3 indicates 0 kurtosis. So again, if we want to report our kurtosis value as something analogous to what we would see in SPSS, I'm going to hit display, and this is just my calculator. I'm going to copy my kurtosis value here, minus 3, and so my kurtosis value for men for the Lock-Wallace is going to be negative 1.63. Okay, so it looks like we do have some negative kurtosis in men. Now I've only got 5 people in this subsample, so I'm not completely surprised, but again, at least based on these indices, doesn't look like there's something that we're too worried about yet. Same thing if we go down, look at the Marlowe Crown. Our skew value, negative 0.27, so not too bad there. Kurtosis value, Stata is listing it as 1.44. Again, if we want to transform that into a 0 kurtosis value, we could do that sort of with calculator. Or if I go up here and hit this display command, this was the last display that I ran, I can also just pull that up down here and change my value and then run that. And so my kurtosis value for the Marlowe Crown for men, I can report that as negative 1.56. And again, this is putting this because again, Stata indicates neutral kurtosis at a value of 3. A lot of programs like SPSS just subtract 3 automatically from the kurtosis value, and so if you wanted to report something similar, your kurtosis value here would be negative 1.56. So again, indicating negative kurtosis on both of these, but not completely out of the question given our small sample size. So we'll note that, but then we'll sort of wait to take a look at graphical stuff. Okay, so distributions are looking at least close to being acceptable, or at least we don't have any huge red flags, particularly given the small sample size here for men. A few more cases for the women. Skew for Lock-Wallace, negative 0.48, not too bad. Skew for Marlowe Crown, negative 0.63, so we're not too worried there. Kurtosis values here, again, if I hit display, let's calculate that previous command and just pull that up. And this is a nice feature of Stata, so you don't have to, if you ran a command and you don't have to have to keep typing it in, you can just sort of choose whatever command that you did there. And so again, kurtosis for the Lock-Wallace for women is going to be negative 1.08. For Marlowe Crown in women, paste that there. Okay, negative 0.60. Okay, so basically across both men and women, skew and kurtosis values are at least looking reasonable here. Although biggest issue is we got the unbalanced design and then the small samples. Okay. But in terms of individual distributions, in terms of our just indices, we're at least not seeing anything too huge yet. Okay. Now, what I might want to do, going through, is I also am going to want to run histograms again for both of these variables for men and women. And so relative to this single sample t-test, a little bit different. What we've got here is we're requesting a histogram for Lock-Wallace, and again we're asking for the number of bins. We're setting the number of bins equal to 7. And again, what I've been doing here, if I hit, I've been setting the number of bins in my graphs to be equal to the square root of the sample size plus 2. So if I hit display, square root of 21, that's the largest sample size, it gives me a square root of 21 is 4.5, so we'll say 5 plus 2 is 7. So we'll go through and request 7 bins for the Lock-Wallace and the Marlowe Crown. Okay, so our histogram, number of bins, we're going to ask it to give us outcomes and frequency. Here we're changing the line color to be black, sort of some Y label stuff. This is just playing around with options in the graph. But then what we've got here at the end is we're saying that we want histograms by gender. Okay, and so what this is going to do is it's going to give me a histogram for men and a histogram for women. Same thing with the Marlowe crown. Okay, so if I go through and I run this command, brings up my histograms. Again, here we have the histogram of the Lock-Wallace for men, histogram Lock-Wallace for women. Again, nothing too terribly surprising that we're seeing in here. Again, some slight negative skew in terms of the distribution of marital satisfaction for women. For men, we've got kind of a square distribution. Again, we've only got 5 people in this sample, so would want to take notes about the shape of these distributions. Nothing concerning in terms of thinking about the distribution of sample means. Nothing too crazy here, but again, we've got a small sample in both cases, so we'd want to be careful and pay close attention, but it doesn't look like there's anything too worrisome here. Okay, so this is our Lock-Wallace. We can also request a histogram for our Marlowe crown scores. Run that. Again, this is looking pretty good for women. Not too bad in terms of distribution, relatively symmetrical here. For the men, we've got just a straight square distribution. Again, 1, 2, 3, 4. There's just our 5 different individuals here. So again, not a great distribution in terms of being normal, but our big concern is weird kind of skewed distributions. A lot of negative kurtosis because it's boxy and flat, but otherwise nothing too concerning in as far as the distributions. Okay, so other thing I want to look at is box and whisker plot. And so if I am looking at my box plot here, I've got box plot of Lock-Wallace over, in this time, gender. And what this is going to do is it's just going to give me box plot for men and for women. Again, this is nice, symmetrical, nothing too extraordinary going on here. Same thing if I were to do the same for the Marlowe crown. Again, we're specifying some additional things, options for the graph here. We don't have to be too concerned about that, but if we go through and run that, we see, so we're saying we want a Y label at 0 to 30 at units of 5, Y scales range 0 to 30. So we just some different options here, but the main thing we want to look at is the box and whisker plot for men and for women. Again, slightly higher median for Marlowe crown than men, sort of our min, max, interquartile range, first or third and first quartiles, all that stuff that we talked about here. But again, nothing too terribly exciting as far as your distributions go. Now I'm going to go through and see if, trying to see if this is still recording. Are we recording? Okay, looks like we still are. Alright, well, never mind that piece of things. Okay, back to what we were doing. Sorry about that. Alright. So, distributions are looking good, or at least not terribly problematic here. So what I want to do now is look for extreme values. Now, based on everything I've looked at, I already know that that I'm not going to get probably anything popping up too much in terms of extreme values, but things get a little bit tricky in Stata when I'm screening for my independent sample t-test, because we need to have something that gives us z-scores separately for each one of our groups. Okay, so here we have men, we have women. The difficulty is we can't just run our z-score command as we did with the single sample test, because if we do that, what it's going to do is it's just going to give us a z-scores based on the mean and standard deviation for the sample as a whole. We need to split things up for men and for women here. So what I've done is written a z-score macro for Stata. Basically, command is, well, what you can do is you can just cut and paste this and drop it into your do file. The only thing that you need to go through and take a look at is make sure that you're changing things for each one of these highlighted values. So here our target is going to be our Lock Wallace and our Marlowe Crown. Okay, so target is just equal to your variable list. Group, this is your grouping variable. In this case, it's going to be gender. And level, this is the range of values for the group. Okay, so here we've got 1, 2. If we go to our gender scores, Stata is telling this is male and female just because we have labels to this, but men are 1, women are 2. So we just let Stata know that our levels for our grouping variable are 1 through 2. Okay, and so if we do this, and again down the road you just go through and modify this as needed, but what we can do is we'll go through everything else you don't have to fool around with, highlight this command, go through and run, and what we'll see is we now have z-scores for Lock Wallace, z-scores for the Marlowe Crown, and we've run these separately, or we've told Stata to run these separately for men and women. Okay. Now if we go down to want to take a look at the min and max, we can go again by sort by gender. This is just going to sort things by our grouping variable gender, and then we're going to say summarize z-scores for Lock Wallace, z-scores for the Marlowe Crown. Okay. So if I go through and I run this, take a look, and this is a good thing to check to make sure that our syntax is ran correctly. We want to see a mean of 0 and a standard deviation of 1. If we didn't, we would see if we didn't actually run these within group, this would be all screwed up. But again, we've got functionally 0. This is 8.2 times 10 to the negative 9th. So this is Stata is just being overly precise. This is 0, 0, 0, 0, standard deviation 1. And so for men, I have a minimum score that's for Lock Wallace is just a little over 1 standard deviation below the mean. Max a little over one standard deviation above the mean. Same thing for my z-scores for the Marlowe Crown. So nothing indicating extreme values for my male subset. For my women, again, low value, a minimum z-score of getting close to 2 standard deviations below, about 1.3 above. Again, close to 2 below, about 1.3 above, but again, z-scores here aren't indicating anything that's looking remotely problematic in terms of extreme values or outlying values, and again, this is consistent with what we saw if we're looking at our histograms here, right, of our Lock Wallace or Marlowe Crown, nothing indicating here. So again, we kind of already knew this. If something popped up as an extreme value, we'd be pretty shocked by this, but the nice thing here is we can just go through and put some numbers and describe what's happening. Okay. So at this point, we've checked accuracy, plausibility. We've gone through and we've taken a look at distributions within our 2 groups. We've looked at histograms, we've looked at box plots, we've looked at extreme values. The only other thing that we would need to do in terms of assumptions for our independent samples t-test is our homogeneity of variance assumption, but we'll look at that in the next video when we're actually running our actual analyses. So again, you can go through and take a look at the example screening here. Again, missing data, missing Lock Wallace and Marlowe Crown scores for a female participant, no evidence of problematic values, removed a case with 26 people in the reduced set. We've got 5 men, talking about skew, kurtosis, histogram stuff here. We've got 21 women, skew, kurtosis. For this subgroup, histograms, box plots, we can go through, talk about that. Outliers, extreme values, not seeing much here, but this is how we might go through and report this for the male and for the female samples separately, and then we'll talk about homogeneity of variance in the next set. So here, what we've got eventually kind of, I guess we'll spoil the next video, but missing minimal, design noticeably unbalanced, some negative kurtosis in men, but limited result of the limited sample. We do, when we get to the Levine's test, some possible violation of homogeneity and variance in social desirability, but it ends up not making a huge deal. And here, just going through and writing up our general recommendation based on our screening. Okay, so that covers screening, just basic screening for procedures for independent sample t-tests. In the next video, what we'll do is we'll walk through actual tests and running effect sizes for the independent sample t. So I'll see if I can get this shut down. We'll pause.